Hello students, welcome to chemistry class. It is the 8th session of the solid state chapter. In previous video we have discussed about the imperfection in solids and classification of crystal defect. In this session we are going to study about the magnetic properties of the solid. Magnetic moment of substance is originated due to two types of motion of electron, or magnetic moment of substance is generated due to two types of motion of electrons. First one is orbital motion around the nucleus. Second one is spin around its own axis. Just here, in every atom, electron revolving around the nucleus. Due to that reason, magnetic moment is produced. Similarly, electron spin around its own axis. Due to that reason, magnetic moment is produced. Here, each electron in an atom behaves like a tiny magnet. As I said already, due to the two motion, one is orbital motion around the nucleus and another is spin around its own axis. Similarly, like Earth, it is revolving around itself. Along with that, it revolves around the sun. Here also same, electron is revolving around the nucleus and also electron spin around its own axis. Due to these two motion of electron, magnetic moment is produced. Here each electron in an atom behaves like a tiny magnet. Magnetic moment is calculated by the formula mu equal to square root of n into n plus 2 Bohr magneton, where n is the number of unpaired electron. Magnetic moment is expressed in terms of Bohr magnetons, that is Bm. 1 Bm or 1 Bohr magneton equal to 9.27 into 10 raised to minus 24 ampere meter square. Next is on the basis of magnetic properties. The substances can be classified into 5 categories. One is paramagnetic, second is diamagnetic, third one is ferromagnetic, fourth one is antiferromagnetic, fifth one is ferrimagnetic. Let us study one by one. Paramagnetic substance or paramagnetism. So these are the substance are weakly attracted by the magnetic field. These are weakly attracted by the magnetic field. Example, O2, Cu plus 2, Fe plus 3, Cr plus 3. So these are the paramagnetic substances. Which are weakly attracted by the magnetic field. Why? Because these are contain unpaired electron, one or more unpaired electron. Hence, these substances are weakly attracted by the magnetic field. For example, see here, Cu plus 2. Cu plus the atomic number of Cu is 29. The electronic configuration of Cu is argon 18. Argon is atomic number of argon 18, and here 3d10 4s1. 18 plus 10, 28 plus 1, 29. Here Cu is present in the plus 2 oxidation state. Means it has lost 2 electrons. Just remove 1 electron here and remove 1 electron here. Means it is a D9 system. D9 means a 3d orbital. Here just put the 3d orbital. 5 subshells are there here. 1, 2, 3, 4, 5. So see here, first electrons are singly occupied. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5. Again 6, 7, 8, 9, 8, and this is a 9. See here, unpaired electron is there in Cu plus 2. Hence this is a paramagnetic substance. Here also Fe plus 3. Here also it contain unpaired electron. Cr plus 3. Here also it contain unpaired electron. Hence, these are called as a paramagnetic substance. Paramagnetic substance means these are the substances which are weakly attracted by the magnetic field due to the presence of unpaired electron. Due to the presence of unpaired electron. Next is diamagnetism. Diamagnetic substances are weakly repelled by the magnetic field. Example H2O, NaCl and C6H6. So here diamagnetic substances are weakly repelled by magnetic field. Why these are weakly repelled by magnetic field? Because here these type of substances do not contain unpaired electron. Do not contain unpaired electron. All the electrons are paired. All the electrons are paired. Hence, all the electrons are paired. Hence, these type of substances are weakly repelled by the magnetic field. Because here, if the electrons are paired, the magnetic moment of this electron is in this direction. The magnetic moment of this electron is in this direction. Hence, magnetic moment of these two electrons get cancel each other. Magnetic moment of these two electrons get cancel each other. Hence, these substances do not contain magnetic moment. When you place this type of substance in the magnetic field, so these type of substances are weakly repelled by the magnetic field. Okay, diamagnetic substances are weakly repelled by the magnetic field because it doesn't contain unpaired electron. It contains only paired electron. In paired electron, magnetic moments are cancelled out. Okay. Next is ferromagnetism. Ferromagnetism, these are the substances which are strongly attracted by the magnetic field are called ferromagnetic substance. The substances which are strongly attracted by magnetic field are called ferromagnetic substances. Example, iron, cobalt, nickel, CrO2, chromium dioxide, etc. These are examples of ferromagnetism, and these are called as ferromagnetic substances because these substances are strongly attracted by the magnetic field. Hence, these are called as ferromagnetic substances. And here they show permanent magnetism even in the absence of magnetic field. These show permanent magnetism even in the absence of magnetic field, whereas in paramagnetism these are not act as a permanent magnets, because here when you apply the magnetic field, then only these are act as a magnets. Because the direction of the magnetic moment of electrons are aligned with the direction of the magnetic field. Hence, these are act as a magnets. When the magnetic field is applied, then only these are act as a magnets. Whereas after the removal of magnetic field, these substances are act as a magnet. Why? Because see here, in solid, the metal ions of ferromagnetic substance are grouped together into small regions called domains. See here, in the solid state, the metal ions of ferromagnetic substance are grouped together into small regions called domains. Or you can take example, if you have 100 atoms, just group into 10 atoms. 10 atoms group, make 10 atoms of groups. So 10 atom groups is called as domains. Okay, so each domain act as a tiny magnet here. Each domain is act as a tiny magnet. When substance is placed in a magnetic field, all domains gets oriented in the direction of the magnetic field. And strong magnetic effect is produced. This ordering of domains, even when the magnetic field is removed and the ferromagnetic substance becomes a permanent magnet. Just see here, when any substance is placed in the magnetic field, when substance is placed in the magnetic field, it contain electrons. Substance contain electron. So electrons are you can say it as a domains. Here the direction of the magnetic field is like this. When you place the substance in the magnetic field, the domains get oriented along the direction of the magnetic field. See here, these direction of the domains is aligned with the direction of the magnetic field. Hence the strong magnetic effect is produced. This ordering of domains, even when the magnetic field is removed and the ferromagnetic substances becomes permanent magnet. See, these are the direction of the different domains. So direction of the different domains are aligned with the direction of the magnetic field. Next, Antiferromagnetism. Certain substances do not show paramagnetism. In spite of containing unpaired electron. In this substance, the magnetic moment of different domains are aligned in opposite direction in equal number. Hence, their effect is cancelled. Such type of substance are called as antiferromagnetic substance. Example, MnO, manganese oxide. It is an example for antiferromagnetic substance. Here magnetic moment is equal to 0. Here zero magnetic moment is produced. Means there is no magnetic moment at all in this type of substances. Once again I'll repeat here. Certain substances do not show paramagnetism in spite of containing unpaired electron. In these substances, the magnetic moment of different domains. See here, magnetic moment of different domains are aligned in opposite direction. See here, it is upward, it is downward, it is upward, it is downward, it is upward, it is downward. So the magnetic moment of different domains are aligned in opposite direction in equal number. See here, 1, 2, 3. 3 domains are in upward direction. So 1, 2, 3. 3 domains are in downward direction. Hence, the magnetic moment of this domain and magnetic moment of this domain cancel each other. Here also magnetic moment of this domain and magnetic moment of this domain cancel each other. Here also same. So magnetic moment of these two domains are cancel each other. Hence net magnetic moment becomes 0. So the example for this type of substance is manganese oxide. Okay. Next is Ferrimagnetism. If the magnetic moment of different domains are aligned in different direction in unequal number. These are weakly attracted by the magnetic field. Such substances are called ferrimagnetic substance. Example, Fe3O4, that is magnetite. Ferrites like Mg(Fe2O4), Zn(Fe2O4). These are the examples of ferrimagnetism. Once again I'll repeat. If the magnetic moment of different domains, see here, magnetic moments of these are the different domains. Magnetic moments of different domains aligned in different directions. Here one, it is in upward direction, it is also upward direction, but it is downward direction. Here these two are in upward direction, but it is a downward direction. So 1, 2, 3, 4. 4 domains are in upward direction, but 2 domains are in downward direction. Hence, see here, the magnetic moments of different domains aligned in a different direction in unequal number, these are weakly attracted by the magnetic field. Such substances are called ferrimagnetic substance. Such substances are called as ferrimagnetic substance. Substance example Fe3O4 and Mg Fe2O4 and Zn Fe2O4. And this type of at a particular temperature we can convert ferrimagnetic substances into paramagnetic substances. That temperature is called as Curie temperature, a temperature at which ferrimagnetic substances can be converted into paramagnetic substances, that is called as Curie temperature. Thank you students. In next class I will discuss electrical properties, that is the last session of solid state chapter. Thank you so much.